Hello and welcome back to Let's Code Physics. Today we are going to finish up our series on the traffic light dilemma, which you just saw in the animation there. The question is, when you see a yellow light, do you brake or do you continue on through the intersection? Obviously, if you're very, very far away, you want to brake. If you're very, very close, you want to continue on. Because, like in the example we just saw, the green car, Ninja here, is going to clear the intersection while the red car is not stopping soon enough for the intersection. Now, I sort of rigged the results there by making a very short traffic light and by having it start turning yellow when they were very close. So let's change these numbers a little bit and let's see if we can come up with a scenario in which Cook makes the right decision and a scenario in which Ninja makes the right decision, and then we'll see if we can come up with a scenario in which neither of their decisions is appropriate and they end up in the intersection regardless. So let's change this D yellow to a 200. I was playing around with this earlier, and I think that works out a little bit more in their favor. And let's leave this thing at 2 for right now. Okay, so let's see what happens. So when they get 200 feet away from the intersection, Cook is going to begin to slow down. Ninja is going to continue on through. So let's see what happens. Let's watch for when the traffic light turns red. All right, we've got a yellow light. Cook's decelerating. Red light. Ninja barrels on through the intersection. Cook stops. He's got just his front bumper there in the intersection. Okay, so here, the stopping was clearly the appropriate thing to do. Continuing is obviously not the appropriate thing to do. If we go back and watch it, I was paying attention to Cook. Light just turned red and Ninja's still barreling on through the intersection. So Ninja's is hopefully not in a car accident at this point. Ninja is driving dangerously at this point. So we've got a scenario where Cook definitely makes the right decision. So D yellow, I'm just making a note here, equals 200. T red equals 2.0 is stopping is good. Okay. Let's try making the distance for the yellow just a little bit shorter, though. Let's make it 150, and let's see what happens. So we run the program, so the light will turn yellow a little bit later this time. All right, Ninja has run the red light, but Cook is in the intersection. So we've actually already found a no-win scenario here, where we've got, let's see, where we've got... Oops, let me do a little tabbing there. We've got D yellow equals 150 and T red equals 2.0. Neither of them is good. So if you're in that situation, neither way is going to keep you out of the intersection when the light turns red. Because if you watch again, let's hit a 5. If we watch again, when this thing turns red, Cook is still going forward, so is Ninja, so there's not really, there's sort of a no-win scenario there. Now, of course, this is rigging the deck a little bit because the traffic light is pretty short. So the average time duration of a yellow light is about 4 seconds for a 45-mile-an-hour road, which is what we're simulating here. So let's be a little bit fair to our civil engineers and make that 4, and let's make this thing 200 again. Let's see, these guys are starting at 250. I may need to increase that just a little bit. We'll see. All right, so let's run this again. Let's see who wins with a 4-second yellow light duration. Okay, so there's the yellow light. Okay, so in this case, you might be able to argue that either of their decisions is fine. Let's watch that again. So Ninja ends up clearing almost the entire intersection before the light turns red. Cook stops just short of the intersection. In fact, I tell you what I'm going to do is I'm going to put in an OR here because I want to see what happens when the light turns red. So I believe this is the OR statement for VPython. Light.color equals color.red. There we go. Let's see. Will it recognize that? So now it should... unsupported operand type for thingy. I may need to cut this. Let me look up what an OR is in VPython. So I got my VPython, I got my Python and my MATLAB confused because it's literally the word OR. So let's see here. Oh, actually, so I want this to be a not equals to because I want it to be whenever it's not red. Okay, let's try that again. Because I want the scene to freeze whenever they reach whenever the light turns red. Oh, actually, no, I want this to be an and, don't I? So while they are both true, there we go. All right. So this thing will freeze when... Okay, so light turned red, the program froze. That's exactly what I wanted. So here, clearly, Cook has made the right call by decelerating. Ninja is in the middle of the intersection. So let's make another note here that for D yellow of 200, T red of 4, stopping is good. Das ist gut. Let's see here. So the next thing I want to try is I want to try making the stopping distance a little bit shorter. Let's make it dramatically shorter. Let's cut it in half to 100. So let's say the light turns yellow when they are 100 feet away from the intersection. And they're going to go through. They're going to keep going. They're going to keep going. Cook is slowing down. Ninja reaches the end of the intersection before the light turns yellow. So Cook here is now the one in the middle of the intersection. So for this case, D yellow of 100 feet and a T red of 4.0. Going is good. I didn't have a scenario yet where going was good. So we've already seen that if the traffic light is too short, you can end up with a no-win scenario. Let's see about for 4 seconds can we come up with a no-win scenario. So let's try splitting the difference. Let's go with a D yellow of 150. And let's see who winds up. All right, light is yellow. Okay, so for 150, going is good. So for 150, going is good. All right, let's split the difference. Let's see here. We've got going and going. Okay, so we've got 150 going, 200 stopping. So let's try 175. All right, light turns yellow. Oh, light has turned red. We're almost in a no-win scenario here. I mean, Ninja is still in the intersection. Cook is also in the intersection. So for a D yellow of 175 and a T red of 4.0, we've got sort of a borderline case, right? I mean, it's kind of hard to tell there. So let's play around near that 175 value a little bit. Let's try going just under it. Let's try 170. This is going to be better. Let's see. Okay, so this one's definitely a little bit better for Ninja. Okay. What about for 170, going is marginally better. Enter. So for a 170, going marginally better. Okay, so if that's at 170, when going is marginally better, going, there we go. Going is marginally better. Let's try going between let's go just a little bit above. Let's try a 180 now. At 5. Okay, light turns yellow. Light turns red. Oh, they are definitely both in the intersection at this point. I mean, you imagine, we're looking at it from the perspective of cars that now have a green light going this way. So a car coming this way is going to have to go around Ninja and then around Cook. So this I think is a pretty good example of a no-win scenario. So if we have a D yellow of 180 and a T red of 4.0, then neither is good. And remember, this is according to the article that I read, which I'll have a link for in the description below. The 4 seconds is about the average. I actually said 4.2. So all right, let's give the civil engineers an extra 0.2 seconds. Let's see how big of a difference that makes. Let's see what we get here. So I haven't changed anything else. We'll see whether this is still a no-win scenario. Oh, things got a little bit better for Ninja. things got just a little bit better for Ninja. Now, technically, he's still moving after that. So as long as the car who's right here doesn't barrel through as soon as this light turns green, then they're not going to clip Ninja. But if they're in a hurry, if they're not looking, it's entirely possible that our friend Ninja, God forbid, could not be in so good a situation. Like a Ninja, I hope you're safe. It occurs to me this is probably not the best way to welcome a new subscriber, is to put him at an intersection during a red light. But my brother puts people on spaceships in faster than light, and they blow up all the time. So it obviously can't be too terribly offensive. Okay, so we've demonstrated using this code that there can be a no-win scenario with a traffic light. Given some standard values. So this is a problem that civil engineers definitely need to look into. It's also a reason why having these photo sensors on traffic lights, they serve two purposes. Not only do they take a picture of the license plate of somebody who runs a red light, but they can also be used to delay the green light on the next signal, the signal of the traffic going this way, to avoid these situations. Now, I did promise I would add in a delay, a reaction time for Cook. That's really only going to make this no-win scenario even worse. But, I said I would do that, so let's go ahead and do that. So let's add T reaction. Let's say Cook is able to react within half a second. And we just saw that 0.2 seconds on the yellow light doesn't make that big a difference. So I'm not expecting this to make a huge difference, but let's try it anyway. So let's see here. As soon as the light turns yellow, I want Cook's reaction time to become time plus T react. So that is the time at which he will react. So if light.color doesn't equal green and time is greater than T react, then he'll start slowing down. Let's run the code again. Again, I don't think this is going to, this isn't going to change Ninja's behavior. So this should actually put Cook. Yeah, it puts Cook a little bit farther into the intersection. There's that Dr. Seuss trend coming out again. It puts Cook further into the intersection while Ninja is still here well short of clearing the intersection. So just something to keep in mind as you're driving, that yes, that panic you feel, there can be a no-win scenario. That doesn't excuse us legally from needing to stop at a red light, but just something to keep in mind that is something that's out there, and now you've seen it with physics. So thanks so much for watching. See you next time. Bye-bye.